the next presenter is authors from, I believe, from Auburn University. Paper number, let me just see, paper number 29. The presenter, I guess, will be in person. So is the presenter already here from Auburn University?
Yes. Are you able
Okay.
to see our screen?
No, not yet. And also no image from the video. Now I can see the screen, yes. You are you are Eric, right?
No, Anoop Satineni.
Okay, Anoop. Okay, welcome, Anoop. The title of the presentation is the use of Boston Dynamics Spot, a robot in support of LiDAR scanning on active construction site. The authors are from Auburn University, US. So Anoop, the floor is yours. You have 8 to 10 minutes.
Thank you. Good morning, good afternoon, good evening, wherever people are watching from. So obviously, this is the topic I'm going to discuss today. Just briefly, I'm going to talk a little bit about the introduction of the topic, a little bit about what we set out to do and what we found, and what we think about it after we finished. So obviously everybody's here is familiar with LiDAR, so I'm not going to spend too much time on it. It's over the last half a decade or so, it's become a reliable source of documenting on-site construction or existing condition assessment, what have you. But LiDAR is a very time-consuming process in the sense that somebody has to go and set up the scanner on a tripod, make sure the settings are all right, and monitor the scan, and then pick up the scanner, move it to another location, and then scan again. And you continue the process, and takes obviously some time. And with the availability of the Boston Dynamics Spot, which is their sort of autonomous ground vehicle, if you would, that can walk around, you have the ability to place a scanner on that robot and then capture a scan using that. And then you can also set it up to where you don't have to continuously monitor the robot. It can walk by itself to specific locations and then gather the scan and then continue on with very little human intervention, if you would. So again, this is the traditional scanning on on a tripod, where you set up the scan and then essentially make sure that the scan takes place, and then you move it to another location. And this is the Boston Dynamics Spot. This is again, kind of looks like a dog, if you would, and it has the ability to, so it's almost a fully self-controlled unit in the sense that it can talk to the scanner, and essentially through modules developed by Trimble, Leica, and Faro, all the manufacturers of scanners. And we actually built that mount to be placed on the scanner itself, on the dog itself, so the scanner can be mounted on that. And then the dog can walk in pretty rugged conditions. It has the ability to sort of navigate by itself. It has a LiDAR. In fact, the instrument that you see on the back behind the Faro is its own LiDAR, and it also has cameras and sensors which allow it to navigate. I'll show you a video or two about how that does that. But the idea is to compare sort of how these two methods of scanning work. So the main question was, is there a difference between point clouds produced by the tripod-based scan and the spot-based scan? So from a methodology perspective, used an experimental setup where we, so I'm not sure who's messing around with my Zoom. So it's spot. So the experiment actually took place on an active construction site, again, to compare the quality of the scan between a tripod or a traditional scan versus a spot-mounted scan. And then also placed in autonomous mode, which meant that we did not interact with the dog as it was doing the scan. We set it up and then we sat aside just to see if it was able to navigate and go get the scans. We basically determined 4 locations where we thought the scanner would need to go and collect the data. And then we also, manually collected the scan with the same scanner, exact same settings. Everything was exactly the same as what the robot did. The construction site itself, the construction site itself was a building that is being constructed on our campus. This is a building that's almost finished. It's that's the name of the building, the Tony and Libba Rain Culinary Science Center. And these are the construction companies, HPM and Bailey Harris. They're sort of Southeastern United States-based companies that were involved. And essentially, this is us trying to get ready to start the scan and using Spot to set it up. And here are the 4 locations that we decided that we're going to have the robot and manual scans to compare. Again, pretty simple setup. You're seeing 2 scanners there, but then we use the same scanner, but just for demonstration, that the one on the right is an older version of the Faro scanner. So that's, again, just a demonstration of what the dog was doing. Here is a LiDAR point cloud of what the data looked like after it was processed. More pictures of the same. So what did we find? The quality, we tried to evaluate it on 2 sort of scales, if you would. Sort of just a visual comparative analysis of what the scans looked like when they were finished. And then look at the registry report of what the data was telling us as far as the accuracy of the scan. There shouldn't be any, but we just wanted to make sure, see if there was. And here's the visual comparison of the 2 scans. So the first thing that pops out is that Spot has a much bigger profile than a tripod in terms of the shadow that is cast. So there is some amount of data that is lost on the ground because of the profile of the physical profile of the robot itself. That's the first thing. And the second thing that you'll also notice is the tripod is at about 5 foot 5 inches or so, and then the dog is only about 2 foot 7 inches. So there is there's some loss of data in terms of being able to capture surfaces that you may want to capture using, sort of, again, most tripods these days, you can extend them up to, several feet in the air. So you're not able to do that with the Spot. So that's again, a major difference. As far as the registry report itself, the data was more or less accurate in both cases. There wasn't any significant difference that we would say that a tripod-based scan is a whole lot better than a manual scan. The difference between 0.7 and 1.6 mm as far as the mean error. Our conclusion is, again, due to the size and shape of Spot, there are some, first of all, you can have autonomous payloads, which means that you can set up the dog and then sort of relax knowing that it will go and collect the data and come back. So there's less manual work involved. There's also, the issues of vantage point, you're standing lots lower to the ground. So the amount of data that you're able to see, the scanner is able to see, is different. I don't know that it's better or worse, but it's different. Also, the shadow that's cast by the robot itself is different compared to a traditional tripod. The issues, elevating the scanner with an altered mount, again, that comes with a different set of challenges because now you're altering the center of gravity of the robot, so it's much more prone to fall, and the equipment itself is fairly expensive, so you don't want that to fall. The other thing that you can do is to eliminate the shadow situation is to increase the number of scans. So because you're not actually going out to do the scan yourself, you can actually increase the number of scans and get the same amount of data as far as eliminating shadows are concerned. So that's an alternative. Anyway, so that's so the dog is actually pretty good at avoiding objects. It's not perfect, but it's actually pretty good. And it also, you may have seen it on YouTube or whatnot, but it also climbs stairs. So you can also program it to capture data on multiple levels if you have, if the dog has the ability to climb stairs. So that's my presentation. I'm happy to answer any questions. Thank you.
All right, thank you very much, Anoop, for your wonderful presentation. Is there any question from the audience, from the auditorium?
Yes.
Okay, please.
I would like to ask about the reasons for the difference between this FAROScan on a tripod or this registration error that you were reporting on one of your slides between FAROScanner on a tripod and FAROScanner fixed to the robot. So why is there difference?
There's very small amount of error. And we're not entirely sure. And our thinking was that if you actually went out with a tripod and captured the data again, it's unlikely that you get the exact same error. So the error is so small that we thought it's not significant.
Was it using automated registration, like the built-in
no, actually,
or did you do it by hand? Because obviously that could add.
So we used Faro only now has announced a new scanner that does auto registration.
Okay.
We actually used Faro Scene to do the registration.
Okay. Quick question. You said you told the robot to go in certain locations and then did the scan. How precisely did the robot manage to get those locations?
Yeah, so the robot has essentially you place targets for the robot to go and stand there. In terms of exact location, we haven't really tested in terms of multiple times to see if it was getting the same location every time. But it was focusing because the target is a crosshair, so it has to be pretty close to what it was looking for. It's not GPS guided or anything.
Yeah, but I think it'd be really interesting information to have actually.
Yeah.
Zubair.
Thank you so much. Thank you for your presentation. We are doing the same thing in France with another scan. So with the Boston Dynamics spot. What about what about vibration, mechanical vibration? Did you study that for the quality of the scan? Right.
Essentially what the dog would do when it was trying to scan is it would go and stand there at the location. So there was no, or at least we didn't notice any vibration. We didn't study that, but just from observation, looking at it, we didn't think there was any more vibration on the dog compared to the tripod.
Okay, thank you.
Okay, thank you for your great presentation. And actually, I have two questions. First, I can see there's a mobile LiDAR scanner on the spot. And I want to ask, is that also used in your research? And the second question is the specific reason that why you use the spot, because actually spot is quite expensive. And there's another autonomous robot that we can use. And I want to hear the answer about that.
Well, we had some money that we needed to spend.
Oh, okay.
But this research grant was about trying to see if it could be used in construction. We had a couple of construction companies trying it out with Boston Dynamics, so we thought that'd be a good experiment to do. But yes, there are other autonomous vehicles that can be used. As far as the onboard LiDAR, actually, the way Spot works, they would not allow us to use the onboard LiDAR to do capture scans. And it's also not really as accurate as a Faro might be. It's only for navigation purposes.
Hey, cool stuff. Couple of questions, actually a follow-up to what the gentleman had before. So these, the terrestrial scanners come with different settings, and the mechanical vibration that it induces depends on the kind of resolution you want to capture with the scan. Did you try different resolutions to see what kind of dynamic capability the Spot has with high frequency vibrations? And the second follow-up is the autonomous capability of the Spot is empowered by your ability to stick markers, give it waypoints, and do this. In a construction site that is fairly dynamic, where the structure is changing, that setup procedure requires time. Did you do anything to compare that with if I had to send a human around and do it? Because you pretty much have to set all this up with the human and then let the Spot do the route. And the human could just carry a tripod and just go ahead and do it. So did you compare these two things?
I'll answer the first question as far as the mechanical vibrations and the settings. We did not experiment with different settings as far as this paper is concerned, but we are working on that, is trying with different settings. We set it up for sort of an interior scan, optimized for interior scan, and we compared sort of to, as far as yes, the short answer to your second question is yes, it's not part of this paper, but we're working on that as far as trying to see what the differences would be.
All right. I think we need to move on. The time is running up, actually. So thank you very much, Anup, again, for your wonderful presentation.